Hi, thanks for joining. In this video, we will learn how to easily cache data to improve performance using two options depending on how you prefer to expose the data to your users. The first option is to cache data from the data mappings, which will improve the performance for anyone who is directly querying the semantic model. The second option is to cache data from ontology views, which only improves performance for users querying the specific views. In a separate video, we show how to use Timbr's job scheduler to schedule a variety of jobs, including caching data mappings or ontology views. If you haven't seen that video, I recommend watching it in addition to this one. Great, so let's begin with caching a data mapping. To do so, we'll head over to the data mapper. Here, we'll select the relevant semantic model that contains the data mapping we'd like to cache. Once chosen, we can see all the data mappings that exist in the data model, which includes the mapping name, the target concept, the data source from where the data is coming from, the last updated date of the mapping, as well as the user who created or modified the mapping. In addition to this information, there's an indication of whether or not a mapping is cached. That indication is the cached icon next to the mapping name. When hovering over the cache icon, we can see the information about the cached mapping, which includes the number of rows cached, the date when the caching took place, as well as the location used to store it. To create a new caching, we'll simply click on the three dots of the mapping of our choice and select Cache Resource. In the window that appears, we'll choose the data source and schema we want to store the cache in. And we can also define the index cache by columns, which is optional. If you're unclear about what the index field refers to, let's quickly explain. A database index is a data structure that improves the speed of data retrieval operations on a database table at the cost of additional writes and storage space to maintain the index data structure. Indexes are used to quickly locate data without having to search every row in a database table every time we want to access the table. Indexes can be created using one or more columns of a database table, providing the basis for both rapid random lookups and efficient access of ordered records. When indexing cache by columns, there is an importance as to the order of the columns we choose. It's important to mention that not all databases support indexing. Another important thing to mention is that if we choose a virtualization engine, for example Databricks, as that's the engine connected to this knowledge graph, we will also see an additional optional field that enables us to partition by a certain column. Partitioning splits the data into multiple groups so we can execute queries on multiple partitions in parallel and complete the query faster. This is a very useful feature to have when dealing with big tables and large amounts of data, so we can apply incremental updates of the cache instead of caching the entire data every time. It's worth noting that partitioning is only supported in Spark and Databricks virtualization engines, and when using a Delta Lake or caching in memory. Once we're done selecting the location and other optional fields, we'll click on Save to save and create the cache. And there it is. We can now see the data mapping is cached. At any point, we can return to the data mapper, click on the three dots again, and choose to either uncache the mapping, refresh the cache, or create a new cache. Great, so now that we've learned how to cache data mappings, let's see how the same process works with ontology views. We'll click on the Model tab and move to Ontology Views. Once again, we'll select the relevant semantic model with the views we'd like to cache. Here, we can see all the views that were created using the virtual data model, and here too, we can see the icon showing which views are cached and which aren't. When clicking on the three dots next to each view, we can see the same options we had in the data mapper. Following the same steps, we'll click on Cache Resource, and in the window that appears, we'll choose the data source and schema we want to store the cache in, and define the index cache by columns if relevant. We'll click on Save to save and start the cache for the new chosen view. And there we have it. As simple as that, we've cached a mapping and a view in just a few clicks. Let's quickly jump over to the Ontology Explorer, where we can explore the semantic data model and see all the cached resources associated with this model. On the top right of the model, we'll click on the Cached Resources button, and we get a list with detailed information regarding all the cached resources we have in this data model. As you can see here, we have the two resources we just cached, both the mapping and the view. For each resource, we can see its name, the date, the resource type being either a mapping or a view. We see the number of rows cached, the data source and schema used in the caching, as well as the partition column if defined. To the right, we can click on Refresh to refresh the resource cache, And we can also click on the trash can to delete the cache altogether. And there you have it. In just a few simple steps, you've learned how to cache both mappings and views, as well as get quick access to all cached resources from the Ontology Explorer. I hope you enjoyed this video. Don't forget to check out the video covering Timbr's job scheduler component, where you can learn how to schedule jobs, including the caching of mappings and views. In addition, I invite you to scroll through our YouTube channel, where you can find a wide variety of tutorial videos for every feature in the platform. We'll see you in our next videos. Thanks for watching and have a great day.